Hi guys, I'm Jason Ompolakya and welcome back to Keymaker channel. In this second episode of Hacking the Engineering Board Exam Series, I decided na ang i-discuss ko is the formula that I developed for helical antenna. May mga past board exam na kasi about sa helical antenna. Nagpapakompute ng power gain, nagpapakompute ng beamwidth. So, siya yung pag-usapan natin in this second episode. I don't want to bore you with all the details, but I'll just discuss some basic information. Okay, so let's start. Let's start with this one. First, pag-uusapan natin yung electromagnetic waves. So, the invisible electromagnetic waves was mathematically predicted by James Clerk Maxwell in 1865. So, yung existence ng invisible electromagnetic waves was mathematically predicted by Maxwell in 1865. And then, yung physical demonstration or the demonstration experimentally was conducted by Heinrich Hertz noong 1887. So, yung physical evidence that the invisible electromagnetic field or the electromagnetic wave is existing was presented by Heinrich Hertz noong 1887. Now, if we talk about electromagnetic propagation, if we speak about electromagnetic propagation, as the name implies, it involves the creation of the electric field and magnetic field in space. And the waves that propagate are called as transverse electromagnetic waves. So, yung electric field natin and yung magnetic field natin are mutually perpendicular with each other. And both of them are also perpendicular to the direction of the propagation. So, kaya nga ang tawag sa kanya is transverse electromagnetic waves because the electric field and magnetic field are mutually perpendicular and also perpendicular with respect to the direction of propagation. And take note of this, that a time-varying electric field induces a magnetic field, and a time-varying magnetic field produces an electric field. So, yung electric field nakakapag-produce ng magnetic field and vice versa. Yung magnetic field nakakapag-produce din ng electric field. Now, let's talk about polarization. Polarization is the physical orientation of the electric field vector in space. Kung napansin niyo yung definition ko, at sa mga books, makikita din naman po din ninyo, so yung polarization is the physical orientation of the electric field vector, hindi magnetic field. It's the physical orientation of the electric field vector in space. Now, if the antenna is vertically mounted, it's vertically polarized. So, if the transmitter is vertically polarized, ideally, for maximum reception of signal, the receiving antenna must also be vertically polarized. If the receiving antenna is horizontally mounted or horizontally polarized, theoretically speaking, dapat wala siyang may receive na signal from a vertically polarized antenna. Yun po yung dapat na concept. So, if the antenna is horizontally mounted or horizontally polarized, ideally speaking, dapat wala siyang ma-receive na signal. But because ang medium naman natin is non-homogeneous, it has a non-uniform distribution of density, ang ibig sabihin nun, makaka-receive pa din ng signal yon because of what we call as Paradise effect or Paradise rotation. Na yung tinatawag nating Paradise rotation, that's the tendency of the electric field vector to rotate in space. Yun yung sa tinatawag nating Paradise rotation. Kaya kahit dapat walang ma-receive na signal yung antenna na nakahiga because of the Paradise effect, nakaka-receive pa din siya kahit paano. But again, as we discussed, theoretically speaking, dapat wala siyang ma-receive na signal. So, yun yung tinatawag nating polarization at mahalaga ang ginagampan ng papel nun. So, the transmitter vertically polarized for maximum reception, the receiving antenna must also be vertically polarized. At ang nire-receive natin, take note, the antenna is receiving the electric field vector. Ito pa yung maganda, puzzle na lang siya. Pwede nyo i-research sa internet, bakit sa radio wave propagation, sa antenna, pag-uusapan natin sa antenna theory, sa radio wave propagation, bakit ang kailangang i-receive is the electric field vector? So, pag ang transmitter mo is vertically mounted, nagge-generate siya ng electric field vector. And then, the receiving antenna must be vertically mounted also for maximum reception. At ang tinatanggap niya is the electric field. So, bakit electric field ang kailangan nating i-receive o ang kailangang i-receive ng antenna? Sabi natin kanina, yung electromagnetic waves is composed of electric field and a magnetic field. So definitely, yung ating TEM or transverse electromagnetic waves has an electric field component and has a magnetic field component. And ideally nga, kung pag-uusapan natin, kung nakahiga yung receiving antenna, wala siyang may receive na signal. Kasi ang dumadating sa kanya, for example, is naka-vertical yung electric field, naka-horizontal yung magnetic field. So, ang na-receive niya is the magnetic field. But walang signal. Bakit pag electric field, nagkakaroon tayo ng induced signal? So, pwede nyo siyang i-research or pwede nyo itanong sa mga nakakaalam kung halimbawang alam nila. Why electric field? Bakit hindi magnetic field? Saka ko na siya sasagutin. So, here's an example of a helical antenna. A helical antenna is typically used for satellite tracking. So, ang typical polarization ng helical antenna, it's circularly polarized. But there are helical antennas na gumagamit ng tinatawag nating elliptical polarization. And here's the formula. This one is, pinicturean ko lang sa Tomasi ito eh. So, the formula for the power gain of a helical antenna is, sabi daw dito, A equal to 10 log 15 multiplied by, in parentheses, pi d over lambda square multiplied by ns over lambda, where A is the antenna gain or power gain in dB, and D is the helix diameter in meters, and N is the number of turns or antipositive integer, and S is for the pitch, and lambda is for the wavelength. Now, kung matatapos nyo itong video na ito, ang gusto kong pinakamatandaan nyo is this one. So, madami na kasi nagdi-discuss ng antenna. Madami na rin ako nadinig na nag-lecture about antenna. But, hindi natatouch itong part na ito. And this is the part that I want to embed sa inyo, sa mga nanonood nitong video na ito. Antenna is a passive device. Kaso may tinatawag tayong power gain. Ano yung power gain na yon? Huwag niyo siyang i-correlate doon sa power gain ng amplifier. Antenna is a passive device, which means the power radiated by a transmitting antenna cannot be greater than the power received by the transmitter. Hindi po posible yun. Antenna is a passive device. Hindi po siya active device. So the power radiated or the power emitting, yung radiated power ng transmitting antenna cannot be greater than the power input or the power received by the transmitter. For example, the transmitter has a power input of halimbawa nating 5 watts. So, ang input power niya is 5 watts and then you have an antenna with a gain of 30 dB. Hindi po pwede na, magkano ba yung 30 dB? 30 dB divided by 10, take the antilog, that's 1,000. Hindi pwede yung antenna mo na may 30 dB gain at yung transmitter mo na may power input na 5 watts. So, that is, ang gain is ratio ng out over in. So, ang output power mo is input power multiplied by gain. So, kung 5 watts yung transmitter power, and then ang gain is 30 dB, that's 1,000. So, that's 5 multiplied by 1,000. Ang output power is 5,000 watts. Hindi po posible yon. In fact, it's less. Kung pag-uusapan natin, kung 5 watts yung input, ang actual output power is less than 5 watts because of losses. Because of the transmission line losses, because of branching loss, because of feed line loss, because of coupling loss, because of feeder loss. Madaming losses along the way bago magpunta doon sa transmitting antenna. Ngayon, yung gain na tinatawag natin sa antenna, eto ngayon yung dapat ninyo matandaan. Gain is the ability of the antenna to focus energy. Or gain is the ability of the antenna to concentrate power in a particular direction at the expense of radiating less in other direction. Hindi mo siya pwedeng i-associate doon sa power ng amplifier. Sabi nga natin, the output power is actually less because kung 5 watts yung transmitter power mo, yung lalabas sa transmitting antenna is less than 5 watts because of the losses in between. Yung gain na pinag-uusapan doon is more of the ability of the antenna to focus energy. Halimbawa, an isotropic antenna na may gain na sabi natin is 0 dB, tapos you have a half-wave dipole na may gain na 2.4 dB, hindi ibig sabihin nun, pag nireceive mo yung signal ng isotropic antenna, at nireceive mo din yung lahat ng signal, hypothetical if we have a receiver that receive all the signal from an isotropic antenna, and then the power from a half-wave dipole antenna, even though the half-wave dipole has a 2.4 dB gain na mas mataas compared sa isotropic na ang gain niya is only 0 dB, hindi ibig sabihin mas malaki yung power output doon sa half-wave dipole. If you receive the signal, essentially, you will receive the same amount of signal if the input power is the same. So yung gain, ulitin natin, is more ability of the antenna to focus energy or concentrate power in a particular direction at the expense of projecting less in other direction. Ayun yan. Now, punta na tayo sa comparison. Ito yung gain in dB. So, binanggit natin 10 log ng 15 multiplied by n, the number of turns multiplied by s or the pitch, then multiplied by the quantity 5d square, or d is the diameter in meters, and divided by lambda cube or the wavelength, also in meters. And the beamwidth is 52 lambda over pi d multiplied by the square root of lambda over ns. Ayan yung formula na commonly found sa mga textbooks. And ito yung formula na ginawa ko. Ito yung shortcut formula na ang gain in dB is approximately equal to 5.74 plus 10 log ng n. Which means, kung nakikita niyo yung formula, yung gain pala is only in this formula na ginawa ko, it's proportional to the number of turns ng helical antenna. And the shortcut beamwidth formula is 104 divided by, again, square root of n. It's still dependent on the number of turns. But I want to manage your expectation. So, yung formula lang dinevelop ko is for ideal condition. If the condition is optimum. Pag halimbawang may lumabas sa board examination, kasi ang goal natin sa board examination is dapat mabilis ka mag-solve. Naikwento ko na yan doon sa previous videos ko. You have only 4 hours and the number of items is 100 items. So, 4 hours multiplied by 60 minutes, that's 240 minutes. Divided by 100 items, which means you have 2.4 minutes per question. So, ang goal natin, kung kaya mong masolve yung isang question as possible, so in this case, you could use my formula. Na halimbawa, during your board examination next year, nag-e-exam ka, nakakita ka, nagpapakompute, calculate the power gain of a helical antenna given yung mga values. So, you have 2.4 minutes. You don't have the luxury of time. So, kung magagawa mo siya as much as possible ng mabilisan, you could use my formula. In less than 10 seconds, nag-compute ka, 5.74 plus 10 log ng, halimbawa, 8. Then, nakuha mo yung value, and then nasa choices. So, markahan mo na yun, and then jump to the next question. Kasi ang goal natin is matapos yung 100 questions ng mabilisan. And then, if you have still time, pag may time ka pa, pwede mong balikan yung questions and i-confirm mo using the standard formula. But again, I want to manage your expectation that the formula is for ideal conditions. Baka may mga cases na hindi alam nung gumagawa ng questions what are those ideal conditions, posibleng hindi lumabas yung tamang sagot. Pakita natin. Ito yung nasa isang textbook, yung Blake. Isa rin yun sa mga commonly used textbook sa ECE for communication. At ang dami ng past board examination na kinopya lang yung questions sa Blake. Hindi mo naman kasi maiiwasan yun as mga board examiners, definitely, yung mga reference nila, syempre sa mga books din naman. And instead na mag-create pa sila ng sarili nilang question, mag-customize pa sila, it will be safer to use yung mga questions na available naman sa mga textbooks. Kaya nga, as much as possible, madami kang mga textbook na mabasa, mas maganda. So in this case, itong mismo example na ito, past board exam question na ito. So ang sabi daw dito, a helical antenna with 8 turns is to be constructed for a frequency of 1.2 gigahertz. So, ang tinatanong dito, ang lumabas sa board examination is yung letter B at yung letter C. Calculate the antenna gain in dBi or dB relative to an isotropic antenna. And yung letter C is calculate the beamwidth. Ito yung solution dun sa textbook. So, the gain is 14.8 dBi and the beamwidth is 36.6. So, ayan yung lumabas sa board examination. So, 14.8 yung sagot and 36.6. Kung alam mo yung formula sa board exam, that's good. Ang malungkot kasi nito sa board examination, napakadami mong kailangang kabisaduhing formula. So, kung kahit paano, alam mo yung shortcut at makakatipid ka ng mga time, mas maganda. So, let's try yung formula ang ginawa ko. Let's try to solve this one. Okay? So, let's compute this one. So, 5.74 plus 10 log, sabi sa problem, 8 turns. So, this one is 8. And then, the answer is 14.77. So, yung sagot dun sa Blake, the answer is 14.8. Yung sagot natin is 14.77 or that's 14.8 dB. So, ayan yung sagot dun. So, the answer is 14.8 dB. Yung long method, okay lang yan. That's okay kung gagamitin mo yan. But you could use the shortcut formula. Hindi naman burdensome sa utak yan. Ang goal nga natin, sabi natin, kung kaya mong isolve ng madalian yung isang problem, that's good. Ang ating goal is to dedicate your time, to dedicate your energy dun sa mga mas mahihirap na question. Doon ka dapat mag-dedicate ng time at energy. Pag yung mga problems na kaya namang i-shortcut or i-hack, kaya nga hacking the engineering board exam series, mas maganda, shortcut method na lang gamitin mo. Ayun yun guys. Now, yung beamwidth naman, the answer is 36.6. And the beamwidth, my shortcut beamwidth formula is 104 divided by square root of n. So kung kukunin natin yung beamwidth, let's get the square root of 8. And then, so 104, that's the formula. Ito yon. Then we divide yung answer na nakuha natin. And the result is 36.76. That's close. Ang tamang sagot is 36.6 degrees. Ang nakuha nating sagot is 36.76. So, ayan po yun. So, sa Blake, yung mga questions doon, karamihan doon are mga past board exam questions na din. Now, mag-proceed tayo doon sa sumunod na tanong. Ito naman. This one is, lumabas po ito sa, ito naman po is sa Tomasi. Galing sa Tomasi ito. So, determine the power gain and beamwidth for an end-fire. So, we're using an end-fire helical antenna with the following parameters. The helix diameter is 0.1 meter, the number of turns is 10, the pitch is 0.05, and the frequency of operation is 500 megahertz. Now, pag ginamit natin yung shortcut formula ko, sabi natin, ang kailangan lang natin is the number of turns. Let's try to use the shortcut formula. Yung formula ang ginawa ko. Yung gain is 5.74. So, 5.74 plus 10 log noong ilang turns to. Sabi daw sa problem sa Tomasi. This one is 10 turns. Okay. Let's compute this one. Ang sagot is 15.74 dB. Pero ang sagot doon sa Tomasi, sa 15.15, this one is 15.15 yung problem, ang sagot nga is 5.25. So, medyo malayo doon sa approximate formula na ginawa ko for ideal condition. So, ito na nga yung problem. Sabi ko sa inyo, pag alam mo yung shortcut, mas maganda. But there are instances na pwedeng hindi siya gumana. In this case, iba yung sagot. Kaya lang, medyo, nung tinitingnan ko siya, medyo questionable. Bakit? Ibalik natin yung slides mismo, yung picture ni, yung lecture mismo sa Tomasi. Ito yung sa Tomasi mismo. Sabi dito, typically, a helical antenna will have between a minimum of 3 or 4 and a maximum of 20 turns. So, yung helical antenna daw has a minimum number of turns 3 or 4 and the maximum is 20 turns. And the power gains are between 17 dB and 20 dB. So, siya na mismo nagsabi, doon na mismo sa Tomasi, ang nakalagay doon, the power gains of the helical antenna is in between, on average, or typical, from 15 dB to 20 dB. So, 15 to 20 daw. Pero dito sa mismong question niya, ang sagot dun ay 5.25. So, yun yung medyo may question tayo ng kaunti. Baka hindi optimum yung condition. So, in that instance, pwede mong gamitin yung long method. So, yun po yung dito sa Tomasi. Now, sabi ko nga sa inyo, yung ginawa kong formula to manage your expectation is for ideal condition or for optimum condition. Kaya pag may mga questions sa board examination, as much as possible, mag-gather ka ng mga shortcut methods. Yun yung goal eh. Yun yung dapat mong gawin eh. So, finish the exam as short time as possible so that pwede mo siyang balikan isa-isa. And ayan po yung doon sa helical antenna. This is just a short video. And before we end, I'll just shout out. Hindi ko alam yung actual meaning ng shout out eh. I'll just want to mention some of the kumbaga students, mga former students ko na nag-comment doon sa isa kong post. So, si Michael Babaw and si Jocelyn Castaneda, saka si Edson Suliman. Ito mga former students ko to sa TUP Manila eh. Way back in 2009, 2010. Medyo hindi ko na matandaan kung what time ko mga naging estudyante yung mga yan. So, mga successful engineers na yan, mga yan. Si Jocelyn Castaneda has his startup company called as Cold and Clark IT Solutions. So, good luck in your company. I would like to mention also Vincent Villaluz II. So, saka si Noel Saino. Hindi ko na ma-mention lahat ha, pasensya na. Also to Mark Anthony Catabona. Si Mark Catabona is one of the best web developer na nakilala ko. So, shout out sa'yo, Mark. And then, kay Gibo Trebs Lirena. Classmate ko to nung elementary eh. Bangis din yan. So, halimaw yan si Gibo Trebs Lirena. And si Erica Manaay. And ito is a former client ko siya sa mga PECE projects ko. So, padami kami mga PECE projects na pinagsamahan yan. Kaso mayaman na to ngayon eh. Nasa ibang company na yata ito. And then si PJ Eclibia and si Dennis Barlaan. So, shout out sa mga yan. Pasensya na kayo, hindi ko alam ibig sabihin ng shout out eh. So, ayan guys. I hope may nakuha kayo sa video. Ang gusto ko nga sabihin, lastly, huwag niyong kakalimutan that pag pag-uusapan natin, antenna gain, antenna power gain, ang antenna is a passive device. So, it's impossible that the output power is greater than the input power. It's actually less because of the losses. So, yun yung mahalagang matutunan ninyo for this one. At yung challenge ko, yung puzzle ko, bakit electric field? Pag ang antenna mo, ang receiving antenna mo, mag-receive ng signal, ang orientation mo dapat is based doon sa orientation ng electric field vector, hindi magnetic field vector. Why? So, kung masasagot nyo, pwedeng mag-comment kayo dito sa aking YouTube channel, dito sa particular video na ito. So, again, guys, thank you. I'm Jason Ompolokyo, and this is Keymaker Channel.